Okay, welcome to practical session 1, basic electrical circuits. So what we've got here is our circuit diagram which we're going to connect up. First thing, we'll draw the circuit diagram and then we're going to connect it up. So we're going to have a look at a power supply, fuse, switch, ammeter, lamp and voltmeter. So connecting that up, we'll draw the positive line up to the fuse, from the fuse to the switch, other side of the switch to the positive of the ammeter, from the ammeter to the lamp, and then from the lamp back to home, back to the power supply, just like dot to dot. Now the voltmeter, as we've discussed in class, goes in parallel with the supply, or the lamp or the load. So we'll do it with the supply, it's probably easiest. The voltmeter, positive goes to positive and negative goes to negative. So that's our basic electrical circuit connected. Now we're going to wire that circuit. So we'll put that to the side. So we've got the power supply. Next thing we need is a fuse. Fuse. And we've got a switch. Then we've got an ammeter. And for the purpose of this exercise, I'm going to use the Fluke digital ammeter, but we'll have a look at an analog ammeter at the end of this prac. So there's my ammeter. And as you note, I'm connecting the circuit up as per the circuit diagram. So fuse, switch, ammeter, lamp. So nice and easy to follow. As you can see, it's in series. We'll get to that. Okay, so onto a lamp. Here's my lamp. It's a 24 volt lamp. And then a voltmeter. So we're going to use the Agilent voltmeter for the purpose of this exercise. Okay, so the first thing I need to do is get a wire. So I'm going to go from the positive of the power supply to the fuse. The lead. So from the positive, and I'm using a red lead, so it's nice and easy colour coordination to find out what's positive, what's negative. From a power supply to the fuse. From the other side of the fuse to the switch. Okay, we can use red or black there, red going in. Okay, from the other side of the switch into the ammeter. So red into the red port of the ammeter, positive of the ammeter. Not so critical on a digital multimeter, well it is critical on a panel meter, which we'll have a look at. And then from there I've got the negative cable running into the lamp, and from the other side of the lamp back to home. Negative. So nice and simple. The only thing we haven't wired up, of course, is the voltmeter. So I'll put the voltmeter there. Okay, and we'll go red for positive, so volts, red for positive, and a black one for negative, and black lead there for negative. Now, that circuit is exactly the same as what we've drawn. Does look a bit messy, but having said that, all the leads are connected, so it's nice and easy to follow. You can see fuse, switch, ammeter, lamp, back to the power supply, and the voltmeter across the power supply. The next thing we're going to do is turn it on. We'll turn the power supply on. Basically we have the current fully clockwise, so it's not current limited, so we know it's going to work with the voltage at a minimum. So as I turn the voltage up, we'll start at say 10 volts. 10 volts. Turn the meter on, of course, and we'll turn the ammeter on as well and make sure it's in amps. Okay, so we're 10 volts, 10 volts. So we'll turn the switch on, and alas, we have the lamp. It's a light. So it's a 24 volt lamp. Now, as we've discussed in class, there's a direct relationship between voltage, resistance, and current. So, as I increase the voltage, we will see that the lamp gets brighter. Up to 20 volts, and the lamp gets significantly brighter. We've got 20 volts, and the current's increased as well. We've got 0.177 of an amp. Now if I was to decrease the voltage, one would assume the lamp would get duller, which it does down to 6 volts or 5 volts. So we're down to 5 volts for the lamp. I'm not sure if we can see that or not, but you can see the lamp very, very dull, down to around 5 volts, and the current's gone down to 0.079 of an amp. Now if we convert that to milliamps, we jump by 3 places to the right hand side, so 1, 2, 3, 0.079 of an amp is equal to 79 milliamps. I'll turn that off. I'll turn the power supply off. The other thing which we'll just go through quickly is using a panel meter. So here we've got a panel milliamp meter, M, little m, big A for the milliamp. So once again, red lead into red hole. I'm going to pick the 500 milliamp scale, so as we noticed before, with the digital meter it was a bit over 50 milliamps, around 79. So we'll go to the negative, the black lead and the negative. We've got to make sure we connect this the right way so the needle goes clockwise, not goes backwards and breaks off. And we've got to make sure we're in the right scale so we don't break the needle. So if I turn that back on and turn the switch on, you'll see that we've got a reading just less than 100 milliamps. As I increase the voltage back up to 20 volts, I'm using the multimeter here to monitor the voltage as well as the power supply. With our practical experiments here at Riverina Institute, we always use our meters, okay, because generally speaking all the meters are calibrated, okay, as opposed this is an idea of voltage and an idea of current, but this is the more accurate readings here and here. So we've got 20 volts there, and we've got around a little bit less than 200 milliamps, so we'll say around 170 milliamps. There's 150, there's 200. And we're on the 500 scale, so that's the maximum reading it can read. The other thing we should note, it's a 24 volt lamp, okay, so if I was to exceed 24 volts on this power supply, or via that meter, by turning the power supply up, that lamp would obviously not work anymore. The filament would go open circuit, or worst case scenario would explode. So we've got to be careful of that we don't put too much voltage into it. I'll just turn it back down and be aware of the workplace health and safety precautions of touching that lamp or touching that fuse. Obviously we wouldn't want to touch that lamp, we'd burn ourselves. And touching the fuse, obviously it's exposed metal there, so we obviously be very aware of not touching the fuse while there's power in the circuit. So I'll turn that off, and thus includes the first experiment.